Welcome back. In this video, we are discussing the advantages of modulation. These are the 6 advantages. First one is it reduces the antenna height. Modulation reduces antenna height. Second one, simultaneous transmission of signals by different broadcasting station, or we can avoid mixing of signals from various broadcasting stations. Third one is multiplexing. That means sending various frequencies through the same channel. For example, TV channel or cable TV. So, using cable TV, we can get so many frequencies through the same channel. Fourth one is reduction in noise and interference. Fifth one is improvement in signal to noise ratio. Sixth one is narrow banding. So take the first one, it reduces the antenna height. First we need to see what is the connection of antenna height with these signals. If we want to transmit a signal, we need to consider the wavelength of the signal also. So the minimum height required for an antenna to transmit a particular signal is lambda by 4. Lambda is the wavelength of that particular signal. So consider one example. Take a signal with the frequency is equal to 15 kilohertz. We need to calculate lambda by 4 because lambda by 4 is the minimum height of the antenna required to transmit this signal of frequency 15 kilohertz. So lambda by 4 is equal to, or lambda is equal to C by F. By calculating this, we get 5000 meters. A height of the antenna with 5000 meters is practically impossible. So we are adapting modulation technique wherein we are superimposing this low frequency signal into a high frequency signal. So consider this high frequency signal 1 megahertz. By taking lambda by 4, we get 75 meters. That means 75 meter height antenna is required to transmit this signal. This height is practically possible. So by using modulation, we reduced the height of the antenna. So we can take so many examples to prove this first point. Second one is simultaneous transmission of signals by different broadcasting stations are possible, or we can avoid mixing of signals using this modulation. So different broadcasting stations can transmit different frequencies by using different carriers to achieve this second point or second advantage. Third one is multiplexing. So multiplexing means that sending various frequencies through the same channel. So for that, after modulation, we will get different frequencies using different carrier waves. Fourth one is reduce noise and interference. We can reduce noise and interference using modulation. Fifth one is improvement in signal to noise ratio. So improvement in signal to noise ratio means that improvement of the signal with respect to noise. That means improvement in SNR means that reduction in noise or improvement of the signal. If it is greater than 1, means that the signal strength is more than noise strength. So the improvement in SNR can be achieved using modulation. Then the next term is narrow banding. Let's see the concept of narrow banding. This is the 7th advantage of modulation. So consider an antenna which can transmit a wide band, that means wide range of frequencies from 50 Hz to 10 kHz. So we know that the antenna height depends on the wavelength. The minimum antenna height is wavelength divided by 4. So if we are taking lambda is equal to, we know that lambda is equal to C by 50 and C by 10 into 10 power 3. We are calculating the wavelength of this wide band. So we are taking a ratio of high wavelength to low wavelength. Okay, so that is C by 50 divided by C by 10 into 10 power 3. So that is equal to 200. The ratio of high wavelength to low wavelength of this wide band is 200. So 200 is a big ratio. Or we can say that there is a single antenna which can transmit wide range of frequencies. So from this wide range, if we calculate the wavelength of this wide range, the wavelength may be vary. Okay, so we cannot transmit this wide band using the same antenna. It is impossible to adjust the height of the antenna always to transmit 50 Hz, 100 Hz, 10 kilohertz, like that. So this wideband transmission is not possible because it is impossible to change the height of the antenna if we want to transmit various frequencies. So we need to convert this wideband to narrowband. So after modulation, we know that after modulation we will get a high frequency signal. So we are superimposing low frequency signal into a high frequency signal. So just add these 50 Hz to high frequency signal, or consider this is the carrier signal 1 MHz. So add this 50 Hz with this 1 MHz signal, we will get one value. Then add this 10 kHz with this 1 MHz high frequency signal, we will get another value. So this wide range of frequencies after modulation are converted to a narrow range of frequencies. So these two new values, we have these two new values. This is the narrowband range. If we are taking the ratio, it is approximately equal to 1. So wide band of frequencies are converted to narrow band of frequencies. That means this band is a narrow band. The frequency variation is very less, and only one antenna or antenna with a particular height is required to transmit this range of frequencies. So this wide band is converted to narrow band. After developing this narrow band, only one antenna with a particular height is enough to transmit this range of frequencies, because the variation is very small. We have seen the ratio is 1. Okay, so this is narrowbanding technique. This is the final advantage of this modulation technique. Thank you.